Okay, so in this question, this is one of the ones that tells us what the resultant is. It's not asking us to find it, it's telling us what it is, and it's telling us the two things that contribute to it. What it doesn't tell us is what the angle is between them, and that's what we're asked to find. So the first thing it says is the pilot wants to fly west. And then in brackets it says that is, the resultant is west. So I'm just going to draw my resultant. Okay, I know that my resultant is going to connect the beginning of this question, or the first vector, to the end of this question, the end of the second vector. Everybody follow? Okay, now they're telling me that the wind, which I'm going to consider to be the second vector, is 25 meters per second due north. So I'm going to make that my second vector, and I'm going to connect it to the end of my resultant. Okay, so this is 25 meters per second. Now, the other vector here is how fast the plane can fly. Sorry, I don't want to interrupt. The plane can fly at 95 meters per second. So that means the plane, if I want to end up going due west and I've got a northerly wind, the plane has to fly somewhat, which way? South. Somewhat south. Not all the way south, but somewhat south. Okay, so here's the velocity of the plane. 95 meters per second. That gets me the heading that I'm looking for to be inside my triangle. Now I heard a few people saying that they got the other angle, which is fine as long as you didn't find this one. Okay? That angle will be 75, but it's not in the right direction. Okay? We don't want to find that one. We want to find the one that's pointing in the direction that the plane is flying, and that's this angle. Everybody follow there? Okay? It points from where it started to where it ends. All right. So I'm going to find this angle just using tan, or sorry, not tan, I'm using sine because I have the hypotenuse and I have the opposite side from the angle. All right, so theta will be the inverse sine, since I'm looking for the angle, of the opposite side, 25, over the hypotenuse, 95. Okay, so I'm getting 15 degrees, and that angle is south of west. Okay, everybody follow me there. So if a question says or uses this wording, you have to watch for this. The boat or the plane wants to do this. If it says that, it's telling you the result. Okay? It's telling you what it's going to end up doing or result doing. Okay? And you're going to have to figure out the pieces of it. It's almost like vector kind of subtraction a little bit. You're getting toward the end of the story without knowing how anybody got there. Okay? You have to figure out how they got there. Okay? All right. So be aware, sometimes those kind of questions come up. Okay. I think we did that one yesterday, right? So at least we did one like it. And we did one on the quiz like that today. Okay, now this one says it's a boat, but it's not the boat in the river kind of question. This is a vector addition question with 2 steps. Okay, so the first step is all the vector addition steps. Okay, and then there's another step after that. Right? So this one's going to take you a little while, right? But it's still vector, it's back to vector components. Okay, it's not a riverboat question. Okay, it's a sailboat question. Right? So, give this one a try. This is about as involved as you would ever get because it's 2 angled vectors. Right? So I'm going to give you a little bit of time on that one. If you're still having trouble with this, let me know so I can come around and kind of see where you're getting tripped up and I can hopefully help you. Okay, just so everyone can kind of check their diagram. Okay, the diagram for this one's going to look as follows. We're going to have the first vector is 20 degrees east of north. So I'm drawing a reference line that's north. Okay, I'm going to go 20 degrees east of that, like so, for 150 kilometers. Okay, so there's my first vector's triangle, and this is 20 degrees in here. All right, my second vector is south of east, so I'm drawing a reference line that's east, and I'm going to go 45 degrees south of that. So something like that. Actually, it might be even a little more than that. Okay, and then I'm going to go 265 meters. So quite a bit longer than the first line I drew. So here's 45 degrees. This is 265 kilometers. Here's X, here's Y. And then my resultant goes from my origin or initial position to my final position, which is here. Okay, there's my diagram for that question. All right, I'll give you some time to get ahead of me on the math, and then we'll look at that. So now that we've got the diagram drawn, we need to find all the x's and all the y's. Okay, so black x is the opposite side in that triangle, so that'll be sine of 20 times 150. So sine of 20 times 150. So we're looking at 51.303. Okay. For y, it's the adjacent side, cos of 20 times 150. Oh, not 220. And so we're looking at 140.954 meters, and this one's, sorry, these are kilometers. Okay, and this one is east. This one is north. Right? Then we got to do the same thing for the red triangle. Okay, but can I save myself some time with the red triangle if I recognize something? Mm-hmm. Yeah. The 45-degree angle. The sides are? The same. Yeah, x and y are the same. Okay, in a 45-degree triangle, the sine of 45 and the cos of 45 are the same number. Okay, because it splits the triangle evenly. All right, so x. All right, we'll just go cos of 45 times 265. All right, we got 187.383. Whoop, 383 kilometers, and that one is east, and y is the same number, 187.383 kilometers, but it is south. Okay, so now that I have all of that information, now I can calculate x and y for the green triangle. All right, so green x, okay, green x is going to be 51.303 plus 187.383. Plus 51.3030215, 238.686. Meters east, okay? And green y, that one I'll have to subtract the two because one goes north and the other goes south. So I'm going to take my 187.383 and I'm going to subtract my 140.954. Starting to feel a seating plan coming on, like deeply. All right, so my y resultant is 46.429. Okay, and that's kilometers, and that one is south. All right, so now that I've got the sides of my resultant's triangle, then I do Pythagorean Theorem. All right, so we'll have our 238.686 squared plus 46.429 squared. All right, so we're looking at a resultant of 243.16. kilometers. I've got to find the vector for that. Okay, the way I drew this, x is the opposite side, so I'm going to have 10 to the minus 1 of 238.686 divided by 46.429, right? Because that's the way I drew the triangle, but you may have drawn it the other way. 238.6863185 divided by 46.42940. Okay, so I'm getting here for my angle to be 79 degrees. And that will be east of south. Okay, but you may have also got 11 degrees south of east if you drew the triangle the other way. Right? In the end, I only have two significant figures here. Okay, so my final answer will be 2.4 times 10 to the 2 meters. Okay, at 79 degrees east of south. Now, that's not where this question ends. There's a second part. Okay? And the second part is actually mathematically very easy. It says if the whole trip takes 12 hours, what was the velocity? All right, how do I calculate velocity? Not distance, but displacement. Did I just calculate that? And they told me the time, right? 12 hours. Now guys, when I give a question like this, if I give a question like this on a test, you would be surprised. About 1/3 of people forget to do the second part. Okay? They get done all of this, and by the time they're all traumatized by all the vector addition, they forgot that all they had to do was a v equals d over t calculation for another 3 marks. Okay? You don't want to lose those 3 marks. You worked hard to get the first part of it. Okay? 2.4 times 10 to the 2 meters, okay, divided by 12, kilometers, okay, divided by 12, and okay, we'll get the same vector on that, so we're looking at 20.3 kilometers per hour. Well, actually, it'll be just 20, because we only have 2 significant figures. 20 kilometers per hour at 79 degrees east of south. You'd be surprised how many people get this far and forget that part. Okay, it's not a separate calculation. Your velocity and your displacement are always in the same direction.
I believe it's 3 significant digits because you have 12 points here.
But that only has 2. So my answer on there is wrong because the 20-degree angle only has 2 signigs, and I used it to calculate some other stuff. Okay. Are we starting to feel a little more confident with being able to draw these? Because that's the hard part. Okay, that just takes practice. Okay, getting faster at these just takes practice. That's why we spent so much time on it this week. Okay. So we have one more. Okay, I want you to try this one. Okay. It's a lot of numbers. Yes, it is. This one actually has like 3 different vectors. So yeah, 3. I would never give you one like this on a test. I would never give you one with 3 vectors on a test, because then it's just how fast can you do it, not how well. All right? But it's more of a realistic situation. Okay. We actually use this part of this movie several times throughout the course. We'll talk about, when we talk about inclined planes, we'll also do a question where he's outrunning the big round ball, big round rock. Okay, so for this one, right, the first part of it, listening please, the first part of it is 25 meters at 30 degrees west of north. Okay, so 30 degrees west of north, I'm going to draw a reference line that's north. I'm going to go 30 degrees to the west of that, okay, for 25 meters. Okay, y and x. Okay, the second one, he runs 46 meters at 18 degrees south of west. All right, so I'm going to draw a reference line that's west. Right, I'm going to go 18 degrees south of that, so it's a pretty thin triangle. Right, and it's a bit longer, obviously, than the first one. I'm kind of running out of room here. 46 meters. Okay. 18 degrees. Here's x, here's y. And then my last vector, he falls down a 10-meter long hill. Oh, sorry, second last vector. There's actually 4 here. Due south. So 10 meters due south. All right, and then 18 meters at 40 degrees east of north. All right, so I've got an east of, so here's my north, okay, 40 degrees east of north for 18 meters would look maybe like that. Okay, and there would be my 18 meters. So his resultant looks something like this. Okay, he goes west a lot more than he goes east over the course of this, well, escape, I guess.
That was close enough.
Okay. Okay, after this, the rest of it is the same as all the others. You got to find a lot of x's and then a lot of y's, and then you got to add all the x's and all the y's together. Instead of 2 x's, it'll be 4 x's. Okay, instead of 2 y's, it's going to be 3. Sorry, there's only going to be 3 x's and it'll be 4 y's. Okay, because the 10-meter one is due south, so it actually doesn't have an x component.
Are we able to bring protractors for this?
You can, but I wouldn't. It takes way too long to draw it that way, and as long as the scale is approximate, it's good enough. Okay? I mean, if you want to actually take the time to draw a scale diagram every time, go right ahead, but don't do it on test day, or you won't finish.
I'm not allowed to bring it?
No, you can bring it. I'm just saying to you, don't get hung up on using it.
Oh,
It takes too long to actually measure them all. No. Approximate is good enough.
I can see.